So we're now going to turn our attention to part 2 of case study ex2, and we'll take a look at some other operators in the Flux class. And there's a whole pile of them. Some of them we've seen before, some of them we haven't seen before. We're going to take a look at things like range, and we're going to take a look at some other stuff that we haven't really looked at, like do finally, in order to do some more creation of random big integers and then checking them asynchronously to see if they are prime. And this time, unlike the first example, part 1, where we did everything in the parallel thread that comes along for the ride with interval, this time we're going to have our own publisher thread and our own subscriber thread, and they're going to publish and subscribe data, and they're going to consume it with 2 threads, not just 1. Again, we'll also show how mono from runnable is used. Okay, so let's go ahead and take a look at this. This is in the same folder, it's just a different part of the example. So we're back in my IntelliJ project for case study ex2. As always, we have our entry point class, which is ex2, where we have test is prime timed, and test is prime async. We looked at test is prime timed in part 1 of the case study. Now we're going to take a look at test is prime async. But as always, both those things get registered. They run in the async task barrier, and the main thread will block till they're done. So let's go ahead and take a look now at the second part of this. This is going to be the test is prime async method. So here's test is prime async. This will test a stream of random big integers to determine which values are prime using an asynchronous Flux stream, and I should probably point out with 2 threads, whereas before we only had 1 thread. Some things are very similar. We have a string buffer that's used to store the results. We have a consumer variable that's used to write the values to the string buffer. And now things start to diverge in a very cool way. So what we're going to do is we're going to use our scheduler's new parallel operator, which we talked about earlier in this sequence. And it's going to go ahead and create ourselves a thread pool with 1 thread. We only need 1 thread here, but we could make more than 1, but we just have 1 thread. And we're going to name that pool subscriber. And that's the thing that's going to be subscribing to process the data that's coming at it from the publisher. So now we're going to use the Flux create factor method. We looked at Flux create before when we were making the timed mechanism, but this time we're going to use an async mechanism. So we're going to have a factor method called make async Flux sync. So let's go look at that. Async and sync sound kind of funny. So this particular method is going to also use a thread pool with a size of 1. And we're going to call this one the publisher. So we're going to use scheduler's new parallel to make ourselves a publisher with 1 thread. And then we're going to use that particular publisher to do all the work we're about to look at here. So this particular example, because I'm always trying to find ways to demonstrate interesting things with different features, this is going to use the range factor method. Remember last time we used interval, where it would kind of clock out values once every half a second. This time we're going to use range, and we're going to start at 1, and we're going to go up to S max iterations, which for this case is 10, but could be whatever we want it to be. And what it's going to do in this particular case is it's going to generate the numbers from 1 up to 10, and we're going to ignore those numbers for various reasons having to do with type system characteristics. We have to convert each of those numbers, which are integers, to an unsigned long. That's just to make the type system happy. It doesn't really do anything. And it's because there's no range long method defined in Project Reactor. I don't know why, but there's not one. Then we go ahead and arrange to emit the random big integers in the publisher thread. So you can see we say subscribe on publisher. And what that means, as you may recall, is all the stuff starting from here will be done in that thread. So the whole range loop, if you will, is all done in the publisher thread. Now, as those values are emitted as quickly as they possibly can, because there's no delay used here, unlike interval, we're going to ignore the values, and instead we're just going to use them to do something S max iteration times. And the thing we're going to do is we're going to generate random big integers using that little function that we showed up here to generate a random big integer within that range. As before, we're going to get rid of anything that's not odd, because there's no way to have something that's prime if it's even. And then we're going to subscribe just like we did before. So we're going to emit values that complete normally using sync next. If things are errors or things complete, we just convert them to complete events, which is just kind of like end of file. And then the last piece of the puzzle here is the doFinally method. Remember, doFinally is kind of this stream destructor, if you will. And that always gets called. And what it's going to do here is when this stream is done, after we've emitted all the values from the range value, the range operator, we're going to dispose of the publisher. Okay, so that's basically going to emit those values. Now, the main difference between this and the previous one is these are all just going to get emitted as quickly as we can, just boom, 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 boom. And you'll see that when we take a look at the log output. How do we get the log output, you may ask? We use doOnNext to log each of the integers. We run this thing. Oh, and so remember, make async flux sync is generating a stream of big integers on the publisher thread. So it's coming from that thread. But on the downstream portion, we're going to use the publishOn method to tell this stream henceforth to run in the subscriber thread. So remember, what happens here is make async flux stream or flux sync will generate these things in a background thread, which is the publisher thread. Then those events come back up through create, and then they end up in this second stream. And this second stream very quickly arranges to run everything in the subscriber thread. The rest of this looks pretty much identical to what we had before. We use checkIf prime. No real difference there. CheckIf prime just goes ahead and uses the prime cache memoizer to do the trick of checking to see if there's already a value associated with the key. If not, it uses the function here, the mapper function, to check if the value is prime. In any case, we end up basically with prime result objects that will indicate whether a number is prime or not. We use the doOnNext action operator to print the results. As before, you can see it'll print whether or not we found it with a prime number or a non-prime number. The last thing we do here is we go ahead and display everything with the from runnable, just like we did before for the previous version. And the other difference here, as we had seen also with the make async flux sync method, we are going to apply the doFinally action operator to dispose of the subscriber thread. So that's how we get rid of the subscriber. And if you go back over here real quick, you can see that we use the same trick to get rid of the publisher thread. So in both cases, we're getting rid of these schedulers when they're no longer needed. That makes sure everything shuts down properly. Okay, so we ran this test before, so let's go take a look at the results. Here's the results from the test is prime async test. You can see that it emits a bunch of values, and you can see it also only emits 6 values here because some of these values were even numbers, and so we ignored them because we're only emitting odd numbers. So these are the values we emit. You can see that there's some duplicates. You can see the one that ends in 9.3 occurs twice. The other ones are not duplicates. And so we're checking to see if things are prime. And of course, when 9.3 shows up the second time, then obviously we don't need to explicitly check to see if it's prime because we've already know it's not prime. We already know its value because we just look it up in the map. The other thing you'll notice is look how much more quickly these values get emitted. So the ones down here get emitted basically every half a second, whereas these guys are just getting blasted out pretty much as quickly as they can. So as a result, it finishes much faster. The other thing to note, as I alluded to before, is we have a publisher thread where the numbers are being created or emitted, and then we have a subscriber thread where they're being checked for primality. So once again, that conceivably makes things run faster, maybe. It all depends. It all depends on how long it takes to create prime numbers and to check them for primality, whether we get a win or not. And we'd have to do some experimentation to figure that out. Okay, so that is the end of the second part of case study ex2 for the Flux operators.